All right, guys, we have worked ourselves up to a point where it's time for another quiz. This quiz will cover sections 7.1 and 7.2, so just those two sections. Today, we're going to go ahead and do some practice questions just so you are ready for the quiz tomorrow. Now, in 7.1, that was the introduction to exponential functions. Now, remember what an exponential function means is that your variable is the exponent. When you graph exponential functions, you are going to get a curve-shaped graph. In order to determine if your exponential function is growth or decay, it is based off of the base, the value that has that exponent. Remember, it is exponential growth if your base is larger than 1. It is exponential decay if your base is in between 0 and 1. Okay, now remember, if there's a negative out front, you do not include the negative in your base. What that negative is it's a reflection across the x-axis. So it's just going into those transformations that we studied throughout the year. So let's go ahead and look at graphing, because that was the first thing we did in 7.1. It says graph the functions by creating a table. When you do your tables, I had you go -2 all the way up to +2. Okay, now it says we're going to go ahead, graph it, state if it's growth or decay. And I like to know that before I actually graph it. In order to determine if it's growth or decay, remember, it's all based off of the base. That's a lot of bases. The base of this function is 1/4. 1/4 is in between 0 and 1. So this is going to be an exponential decay function. Now, when you go ahead and you put this in the calculator, if you want to use 1/4, put the fraction in, awesome. If you are more comfortable turning 1/4 into 0.25, go for it. I'm good either way. 1/4 and 0.25, they are equal value. So you're going to end up with the same graph, the same solution, okay? So let's say I do 0.25. 0.25 to the power of, and again, I like to put that exponent in parentheses so that way it's easy to find when I want to change this. When I have 0.25 to the power of -2, I get 16. To the power of -1, I get 4. Anything to the power of 0, remember that's a 1. Well, if I have 0.25 to the power of 1, I get 0.25. And last but certainly not least, if I put in a 2, I get 0.06. Okay, so far, we identified that it's going to be exponential decay. We filled out our table, -2 to 2. Now what we need to do is go ahead and graph it. Okay, so I know I have to go to the left 2 units, and I have to go to the right 2, because my table was -2 to 2. Now going upwards, I have to go up to 16, so I'm going to go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, now when I graph this, I go to the left 2, up 16, left 1, up 4, 0, up 1. Now since I went by 2s, remember it's going to be in between the 0 and the 2. 1 is 0.25 and 2 is 0.06. When you curve it, when you graph it, make sure you do get a curve. It's exponential decay, so it is curving downwards. Your asymptote would be your x-axis, and that is it for the first example. Let's look at one more. Okay, this time, again, we are graphing by making a table. -2, -1, 0, 1, and 2. The function is 14 times 1.4 to the power of x. Your base is the number that has the exponent. So for us, it's 1.4. This 14 is a vertical stretch. Your base is only 1.4. 1.4 is greater than 1, so this is an example of exponential growth. So I'm going to go ahead and fill this into my calculator so I can complete my XY table. So I have 14. In parentheses, they gave us 1.4 to the power of. My first exponent is -2. If I fill that in, oops, sorry, I accidentally hit a minus sign. There we go. 7.14. Now, as long as I was careful right away and I have the function correct, I can just up arrow and change the exponent. I want to go from a -2 to a -1. Now I have 10. If I go ahead and I change my exponent to a 0, I'm deleting the negative, changing the 1 to a 0, and I get 14. up arrow. Change the exponent to a 1. I got 19.6. Up arrow. Change the 1 to a 2, and I got 27.44. So last step, and this will conclude our review from day 1, we're going to go ahead and graph this thing. Again, my x's go -2 to 2, so I have to go to the left 2 units, and I have to go to the right 2 units. Going upwards, my y value, I have to go up to 27, so I'm going to go by 5s this time. 5, 10, 15, 20, 25, and my 27 will be a little bit off of the graph. So if I go to the left, -2, go to the left 2, up 7. Go to the left 1, up 10. 0 is up 14, 1 is up almost to the 20, 2 is up and even off the graph. So again, when I connect these, I do notice that I'm definitely getting that curve-shaped graph, which is a characteristic of an exponential function. This is what we did on day 1 of chapter 7. Can you identify a base? From the base, can you tell if it's growth or decay? Can you complete an XY table, graph the function, make sure you get a curve shape? Okay, now day 2. Day 2 is where you were writing your own functions. So remember the formula, I'll just put it right here. It's the starting amount, 1 plus or minus the rate to the power of t. Now, A is your starting amount. So whether we're looking at purchasing a car or maybe collecting baseball cards, what is the starting value? Then in parentheses, it's 1. If your value is going up, if it's exponential growth, you're adding. If it's exponential decay, the value is decreasing, it's minus. The rate is your percentage as a decimal. That all is closed off in parentheses to the power of t. So let's go ahead and look at 3 of these. Suppose that the number of bacteria in a culture was 1,000 on Monday. The number has been increasing, so it's going to be plus, at a rate of 50% per day since then. Write a function representing the growth of the culture. So A, the start was 1,000. That's how many bacteria there were at the beginning of the study. On Monday, there were 1,000 bacteria. Then it's always the number 1. In this scenario, the number is increasing, so it's a plus, at a rate. Rate is your percentage turned to a decimal. 50% is 0.5 to the power of t. That is it. All they wanted you to do is write a function to represent the situation. You're done. Okay, here's another one. This is true, you guys. Okay, so if anybody who's been to New York City and been to Manhattan, check this out. Okay, in the year 1626, the Dutch bought Manhattan Island. Okay, so Manhattan is part of New York City. They bought it for $24 worth of merchandise. Picture buying Manhattan for $24. Granted, this was back in 1626, but it's like mind-blowing to even try to consider that, okay? Suppose that instead of having $24 worth of merchandise, they received $24. They invested it into an account that paid 3.5% interest each year. So remember, when you invest and you are given interest, that's exponential growth. Your money is going to be, you're getting more money, okay, as that interest is added to your account. Write a function representing the value. So at the beginning, the Dutch bought Manhattan for $24 worth of merchandise. Had they invested $24 instead, the value would have been 1 plus 3.5% is 0.3 or 0.035. Remember, you have to move that decimal to the left 2 times, to the power of t. So that is a function representing the value. Now it says to use your function. Okay, let's go ahead to 2008. Let's just say that there was an account and ancestors wrote letters and somehow it got passed down, and somewhere in 2008 somebody received the bank account code where they could go get this money out. Okay, you have to figure out how much time has passed. Okay, and it's based off of years. Well, if I take 2008, that's when you were going to take that money out. It was put in there in 1626. If I take 2008 minus 1626, you'll find that that was 382 years that passed. So that's what t would be. So here's my function. 24 is the initial amount. 1 plus 0.035. It was in the bank for 382 years. Let's calculate this. 24, open a parenthesis, 1 plus 0.035, close it to the power of 382, and you would get $12,229,955.10. That's how much that investment would be worth in 2008. But still, if you've ever been to New York City, even trying to picture purchasing Manhattan for this amount is still crazy. So kind of a cool real life math scenario for you. One more and then we are halfway done because we will be done with our review for 7.1. Gina buys a car for $13,500. Assume that its value will decrease. Okay, that's the normal trend when you buy vehicles. Let's say that it decreases by 15% per year. Write an exponential function to model the value of the car. So at the beginning, the value was $13,500. That's when Gina bought the car. Then it's 1 minus, the reason it's a minus is because the value is decreasing. It's decreasing at 15%, so 0.15 to the power of t, and t represents years. So guys, that's everything that you need to know for 7.1. Now 7.2, I loved inverses. 7.2 is our inverse chapter. Now remember the definition of an inverse. It says that you switch your x and your y value. Now x is your domain, y is your range. So your inverse is going to have a flip-flopped domain and range from your original relation. And a relation is just a set of ordered pairs, okay? When you graph inverses, you should get a reflection over that line, that diagonal line that goes through the coordinate plane, y equals x. Well, let's go ahead and do some review for 7.2. This says first, graph the relation. Now remember, definition of a relation, we just have a set of ordered pairs. So it can be a table, it can be a map, it can be coordinates on a grid. In our case, we have a table. So we're gonna go ahead and graph our relation. Stay at 0, so don't go left or right, go up 3. Go to the right 1, go up 4. Go to the right 2, go up 5. Go to the right 4, go up 6. Go to the right 6, go up 7, and connect. Now they want us to find our domain and our range. Now remember, your domain are your x values. They had us connect because this is the same as what they had us do in 7.2, okay? Your smallest x value is at 0. Your largest x value is at 6. So I could either look at the graph to figure that out, or I could look at the table knowing I'm going to connect the points. Smallest x is 0, largest x is 6. So x is in between 0 and 6. And make sure you have the little lines underneath because it does include those points. Now y, same thing, y runs up and down. The lowest y value is a 3. The highest y value is a 7. I can look at the graph to see that, or I could look at the table. My y's go from 3 to 7. So 3 is less than or equal to y, which is less than or equal to 7. Now they want us to state the inverse table. Remember, definition of inverse, switch your x and y. So 0, 3 becomes 3, 0. 1, 4 becomes 4, 1. 2, 5 becomes 5, 2. 4, 6 becomes 6, 4. 6, 7 becomes 7, 6. Now we're going to plot those ordered pairs. So go to the right 3, stay at 0. Go to the right 4 and up 1. Right 5, up 2. Right 6, up 4. Right 7, up 6. And we connect. Now notice, if I did have that line, y equals x, our relation and inverse, they are a reflection over that line. Okay, now they want us to say the domain and range for both the original function and the inverse function. So let's go ahead and do that. So domain and range. Now here's the inverse function. Looking at the x's go from 3 to 7. So your x values are in between 3 and 7. And again, notice that that was our previous range. Our range, so if I'm looking up and downwards, the lowest value is 0, the highest value is 6. So my y values are in between 0 and 6. And again, notice the range for the inverse was the domain for my original relation. Okay, so that was the first part of 7.2. Then again, they wanted you to look at graphing as well as finding the inverse of an equation versus just a relation, a set of ordered pairs, and double checking that you still get this relationship. So we have graph f of x equals 2x plus 1. Remember, f of x is interchangeable with y. So I can have y equals 2x plus 1. If I go to graph this, this is y equals mx plus b form from back in Algebra 1. So I'm going to go ahead and just put some little markings on my coordinate plane. You go ahead and do that too. Okay, if I'm graphing this, whatever's, whatever's after x, that is your y-intercept. So from your origin, because it's plus 1, you go up 1. Now your slope is the value that is in front of x. It's positive. 2 is the same as 2 over 1. So I go up 2 over 1. There is your line. From geometry, you would have learned that it only takes 2 points to make a line. Now they want us to find the inverse. Definition of inverse, you switch x and y. Now to find your inverse, you have to solve for y. So step 1, I'm going to take this plus 1 and move it over. So x minus 1 equals 2y. To get y by itself, I have to divide everything by a 2. Now because I'm turning this into y equals mx plus b form, I do want to simplify it a little bit more than this. If I have x over 2, that's the same thing as 1/2 x. A variable over a denominator is the same thing as 1 over that denominator times the value. So had this been x over 3, it would have been 1/3 x. X over 5, it would have been 1/5 x. We have x over 2, that's the same thing as 1/2 x. The reason I'm doing this is because now I have my slope. My slope is up 1 over 2, up 1 over 2. Okay, minus 1 over 2, that would be my y-intercept. You don't always have to start at an intersection. Because this is minus, I'm going down. You go down 1/2 of a unit. Now my slope, I go up 1 over 2. There's my 2 points. I can go ahead and connect them. Here's my imaginary line. Yes, I do still have that reflection. Okay, now the next part. This is the part on the quiz where you guys, it's worth a lot of points. I'm giving you 3 points for each question because technically you have to do all 3 steps to do this. And what I mean by 3 steps, let's look at it now. Step 1, this is f of x. The definition of an inverse says you have to switch x and y. Well, you can't switch x and y if you don't even have a y. So step 1, you change f of x to x. Or sorry, you change f of x to y. That is your first point. Step 2, definition of an inverse, you switch x and y. So this becomes x equals 2y. That's 2 points. Your third point, you want to solve for y, so I need to divide both sides by 2, so x over 2 equals y. There are your 3 points. Let's do a couple more. Step 1, f of x changes into y. There's step 1. That's 1 point. Step 2, definition of an inverse, your y becomes your x and your x becomes a y. There's your second point. Last point, you have to solve for y. So on the same side as y but not touching is a minus 5. So step 1, I'm going to add that 5 over. Now to get y by itself, this is y divided by 4. So I need to multiply 4 to each side. So y equals, we isolated y. When I multiplied the 4 here, this is 1 term times 2 terms. This 4 would have to go to both terms. So 4 times x is 4x. 4 times 5 is 20. That would be your inverse. One more question like this, just to make sure we've got it. Okay, f of x is y. 3x minus 5 over 2. There is step 1. Change f of x to y. Step 2, definition of an inverse. You have to switch your x and your y. Sorry, my dog's excited because the mailman's here. X equals 3y minus 5 over 2. There's your second point. Now last step, I want to solve for y. So the first thing I would do is cancel the denominator, so I multiply a 2 over. So 2x equals 3y minus 5. I'm not done because you have to get y by itself. So I would add 5. So 2x plus 5 equals 3y. Last step, if I want to isolate y, I have to divide by 3. So I'd have 2x plus 5 over 3 equals y. That is your inverse. Okay. Last part. Now, if you looked ahead in the book at any of these questions, they do consider problems like this inverses. Okay. This is where you are going to be given a scenario and you are going to write it as an equation. You already know the solution, okay? And that's why they're calling this an inverse. So let's go ahead and just do one, and I'll walk you through why it's an inverse as we start, okay? Sam's computer repair bill, it includes $210 for parts. So that's what Sam has to pay for parts. Then it's $55 per hour of labor. Write a function to represent the situation and then use it to find the number of hours of labor if Sam's bill was $402.50, okay? Now $210, that is a constant bill, okay? That's just the parts. Your variable goes with, it's $55 per hour. Okay, so if it's only 1 hour, it's $55. But as soon as you go more than 1 hour, you have to pay that as many times as hours that were worked on the computer. So it'd be $55 per hour. The bill equals $402.50. Now, the reason why they're calling it an inverse, it's very similar to the idea of the problems where we worked backwards. But sometimes rather than working backwards, it's a little bit easier to just write an equation and solve it. It's still considered an inverse because you already know the answer. You're going backwards. You know the solution. You want to find out information from the problem. So now all you have to do, guys, is go ahead and solve this equation. So step 1, minus the 210 over. So I would have 55H equals, if I take 402.50 minus 210, you get 192.50. Divide both sides by 55. 192.50 divided by 55 is 3.5, and that 3.5, what it's representing are hours. One more like this, because this is the way that I put them on the test, okay? A theater sells tickets for $22. So that would mean each, every time you buy a ticket, it's $22. If you pay by a credit card, the theater adds a service charge of $3.50 per entire order. So what that means is if I buy 5 tickets, I don't have to pay the $3.50 on every ticket, just one time for that complete order, okay? Write a function to represent the situation and then use it to find the number of tickets purchased if the credit card bill was $157.50, okay? So it's $22 per ticket. Obviously, if you have a credit card bill, you use your credit card. If you use your credit card bill, there is a charge of $3.50 per order. Your bill was equal to $157.50. There is your function. It is an inverse because you already know the answer. You're working backwards to solve for t. All you're doing here, guys, is solving an equation. If I minus $3.50, I would have 22t equals 157.50 minus 350 is 154. If I take 154 and I divide the 22 over, t would represent 7 tickets. That is everything you will see on the quiz. You guys will knock it out of the park. I just know it. I hope you're having a great day and enjoying some of the nice weather we've been getting. I miss you so much. Virtual hug. Talk to you later.